Okay, there are some basic integrals that I expect you to know before doing this problem. So can you tell me what integrals that you already know?
Wait, can you repeat that, please?
What are the integrals that you know of? So for example, can you tell me what is the integral of x raised to n?
X of n.
Yeah,
Let me see. So it would be x of n plus one over n plus one.
fantastic. And make sure when you're doing indefinite integrals, you put the plus c as constant.
Yes, a plus c, right? Yes,
Okay,
plus.
okay. The other ones that I should expect you to know is integral of sine x and integral of cosine x. Can you tell me
All right.
these guys?
So yes. So sine of x, that was negative cos plus c. Negative
Good.
cos of x plus c. And then that's positive sine of x plus c.
Yes. Okay. How about integral of e raised to x?
Ex plus c.
Yes. Okay. These are the very basic integrals. Make a note of this, and if there are any advanced integrals, I'll let you know.
All right, got it.
Okay. Let's see if I can. Okay. With that spirit, let's do the first one. What do you think?
Um, sir, will I be able to access the recording to this meeting later? Or?
You can record the session on your computer, I guess. Can you click like Alt R or click at the recording button? I'm already recording the session, so I will have it on my computer. I can share it with you later.
Oh yes, that would be great.
Wonderful. Okay. Also, about my tutoring style, I won't be giving you away the answers to you directly. I will guide you through the process. I hope
Yes,
that's
right.
fine.
That's what I prefer.
Okay, good. Okay, so with that spirit, let's tackle the first problem. What do you think about the first problem?
This one is fine. I can do this one.
Oh, that's wonderful. How about the second one?
Second one, I might need to like review over this a bit.
So, can you recall some of the trig identities that you know? In particular, the
Yeah.
Pythagorean
So
identity.
cos to x minus one should be equal to. Oh yeah, that's equal to one. Yeah.
Yeah. So can you,
Cos to minus one should equal to. Shouldn't it be equal to what is it? Sine of x, sine squared of x, or is it negative sine squared of x?
which one, positive or negative?
The top portion.
No, no, I mean, which one
2x.
is it? Is it the positive sin x or the negative sign?
Yes, with the negative sine x, yes.
Negative sin x. Wonderful, wonderful. So it's going to be negative sine square x over sine x. And how do you simplify that?
You divide that and then you negative sine.
Negative sine x. Wonderful. Yeah. And you're almost done. Come on. Can you do the final step?
Yes. So since it's negative and you get a negative, it should be positive cos x plus c.
You're done. Good job.
Thank you.
Okay. This one is about the u substitution. So if you want, we can keep this for later.
Let's see.
Okay. So for
Yeah.
now,
Actually, yeah. This one is it's u substitution.
yes.
I thought it was the one with the ln. I think.
But before that, you have to do u substitution. Okay. We will keep
Okay.
this for later. Let's do the easier one first. How about this one?
So since that's cosecant squared, it should be negative 3 cotangent x plus c.
That's wonderful. Fantastic. Okay. Again, this one is using use substitution, so let's leave at that. How about this one? It has
This
radicals in
one,
it.
this one's good, right? So let me see. So for this one, you change it first. You change the integral, the thing within the you do the integral sign, and then you do x 8/3,
Okay.
right? And then yeah, dx, and then then you do the integral, so then you get x. Oh, I think it's 11/3, and then you divide that by 11/3.
Yeah. Instead, I could multiply by 3 over 11.
Yeah, right.
Right?
Yeah.
Yeah. Okay. Good, good, good. Okay. Okay. I'm seeing that you're already comfortable with a lot of these, so I'm gonna ignore a lot of them. How about this one? Can you just read out loud what the answer should be?
That's ex plus, let me see. Yeah, 4x squared
Yep,
plus c.
got it. Wonderful. How about this one?
This one. Don't you have to like multiply the x by the 3x and the 4
That's
first?
wonderful. Yes. So what do you get?
You get 3x squared plus 4x
Okay.
and then dx, yeah. And then you get 3x cubed over 3, that simplifies out to x cubed. And then you get 4x squared over 2, so then you get 2x squared
Going
plus
for the
c.
plus. Wonderful. Okay. Okay. Okay, I expect you to do the rest of them yourself. For now, let's do this one. Sorry about that. Okay. Take a minute to read the data given and then tell me what you think about it.
All right, but we're gonna go back to the ones that I was struggling with, right?
Yeah, yeah, the use substitution ones, right?
Substitutions. So
Yeah, yeah,
that was numbers 3 and 5. So we're gonna go back to 3 and 5.
three,
Everything else was
5, and maybe 12.
yes, 3, 5,
Yeah,
and 12.
yeah, we will come back to that.
Yeah.
Okay, try this one. This one is the derivative of it.
All right, good. So let me see. F of x general solution. Okay. So from what I remember, 3. Okay, so you put the integral 3 of x plus 5 dx, right?
I hope
And
you're
then you
finding
just
f of x. Is that what you do?
yes, right.
Okay,
So
good.
then you do then you do let me see. Yeah, you do the integral of that. Yeah. 5x plus c. Right. And then you put in f of 2. Okay. So then you put in 10 equals to, and then wherever the x is, you put in 2. So 3 times 2 squared over 2.
Does that become a 6?
Yeah. And then plus yeah, 10 plus c.
Okay.
And then you subtract what's on that side. Yeah. C equals
So,
-6.
wonderful. So your final answer.
And I think we put like a uppercase F for that one. Yes. And
Uh,
then yeah.
no, I would still put the lowercase because they're always using the lowercase.
All right. You
Right?
got it. Okay, good.
So 5 minus. Is that what you were wondering?
Yes.
Good. Good, good, good. So I think you are comfortable with this part. Let's keep going with all of this. I'm gonna do one with okay, I'm gonna do one with trig and then one with higher orders. Let's do this one. This 14. Okay, what do you do?
So let me see. So we're doing this is 14, right?
Yep.
Solve the differential equation cos plus 1, cos of x plus 1, f of 0, wait, f of 0 equals 5. Okay. So let's see the integral of cos of x plus 1 dx, and you put in parentheses. So let's see, cos of x would equal to sorry, cos of x would equal to, let me see, because it leaves out a positive sign. So sine of x, then plus 1x plus c.
Good. Now put in the initial conditions.
So this one. So then you're gonna do 5 equals to, let me rewrite this. All right. So then you're gonna do 5 of sine of, what was it, 0 plus 1 times 0. So let's see. 5 equals, okay, sine at 0 is, I forgot what that was.
So yeah, you need to recall some of your trig stuff when you're doing calculus. Sine of 0 turns out to be 0.
Right. So I think it wasn't 0. I think it was 1.
Oh,
I don't
cos
know,
of 0
0?
is 1. Yeah, sine 0 is 0.
Sine of 0 is 1, right? So let me see. Yeah, equals 0. So it's C equals 0?
Oh, think carefully. You have a 0, 0, and C, and then a 5 here. What do you do?
Yeah. Oh, sorry. All right. So then that would be normally 5.
C is 5.
Or
And therefore,
yeah.
particular solution is C with 5. Is that what you got?
So yes, sine x plus 1x plus 5.
Fantastic. Okay. I'm gonna do one with higher order. So let's do this one, 17. Whichever you like, 17 or 18, whichever you prefer.
17 or 18. Let me look at them. Yeah, I would like 18.
18. Okay, good choice. Okay. This is the second derivative. So what do you do about it?
Yeah. So let me see. So for this one, you do f prime of x equals to 4 x, and you put the integral, and then you put dx
Right.
around that, and then you bring that down, then you get 4x squared over 2 plus c, and then you get 2x squared plus c. So that's that for that
Okay.
first. Right. And then you input what the first derivative of f is.
Good.
So this one's for f prime of 6 equals to 10. So then we're gonna do 10 is equivalent to 6 squared plus c. So then that's gonna equal to 6 squared equals 12. No, not 12, sorry. 6 squared equals 36 times 2 equals 72 plus c. Then you subtract the 72, and then you get negative 62 equals c. So
Fantastic.
then, let's see, f of 2. All right, then you do that's it. Then you do the thing again. So it was f prime of x equals to
It's just
um
f of x, not f prime anymore.
f of x, not f prime of x. Okay. Third plus. Do you just add like the what's it called? Do you just add what was the result of C from the previous?
Yeah, obviously you said so. Put the C in and then integrate, of course.
So would it be 2x squared minus 62 plus C? Or
No, no,
no,
no.
or
Make sure
did I?
you're integrating that. 2x squared
Right,
minus 62. Yes. Once you integrate,
so
leave it.
right. Okay, then. So dx. Um, so what we're gonna do now, you're gonna do 2x cubed over 3 minus 62x plus C.
Yeah, let's not call it C because we already know what C is. Let's call it some other. Let's call it K.
All right, good. So then next, then you're just gonna put that back into f of 2 equals 0. So then you have 0 equals to 2 times 2 cubed over 3 minus 62 times 2 plus c. I mean k, sorry. So then you get 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 equals 8 times 2 equals to 16. 16 divided by 3. So that's going to be, is it 15? No, not 15. 5.5.
But no, it won't be. You should
Oh
leave it
no,
as a
just put a
fraction.
fraction. Fraction, yeah. So then that's going to be 16 over 3 minus 62 times 2 quickly. 100 and negative 124 plus
Yeah.
c. Then you subtract 124 Oh no, then you add 124 and then you subtract 16 over 3 to the other side.
Good.
Do I just leave it in like fraction form or do I do it in decimal form?
A fraction, but a single fraction.
Okay, so I'd have to make the 124 a fraction as well.
Yep.
And then just add the at the end.
Yep.
Oh wait, never mind. Um,
Are you suggesting 124 minus 16 over 3?
yeah,
Yeah. You need to tell me what is it as a single fraction.
as a single fraction. Okay, got it. Um, yeah, that's going to equal 3 times 16. So which one am I turning into? Which like am I turning this 16 over 3 into a whole number?
Well, that is not possible because 16 is not divisible by 3.
Right.
Yeah. So instead, could you make a common denominator?
Right.
Make a common
Common
denominator
denominator.
of
Okay.
3.
Yeah, 3.
What
So
do you
turn the
convert? What?
120.
Yeah. What does that become?
So I just multiply that by 1/3.
Multiply by 3. Yes.
Okay.
Does that give you something along the lines of 372?
Should.
Yep. And then you're subtracting a 16th. So does that make sense?
Um, why multiply it by 3? Because
Oh, good question. Uh,
uh
you already have
shouldn't it be
124 over 1, right?
right?
You want
So I
to
should
make the
multiply.
denominator by 3. So therefore, to make the fraction the same, you multiply the numerator as well. You don't want to change the fraction, do you?
Right. Oh, okay. So 372 over 3.
And then subtract the 16 over 3.
So then is 60 and 350, 356. So it's
That should
356 over 3.
got it. And make sure you report your final answer as f of x equals all of this with the value of k as 356 over 3. This should be your final result.
So f of x cubed over 3 minus 356 over 3. Alright, got it. Yeah, okay.
Okay, do you
I'm
have any questions about
just
this?
I'm just checking to make sure. Okay. So in terms of like changing the fractions, like why would you make it like 3 over 3 instead of like 1 over 3?
You want a denominator of 3, right? So that you can combine the denominators, right?
But okay.
Yeah.
I
So
think
the
I
question is, how do you convert this 1 to a 3? You multiply by 3. But you don't want to change the fraction. Whatever you do at the bottom, you should do at the top as well, right? To maintain the equality of the fraction. So that's why you multiply by a 3. Does that answer your question? Do you have any other questions?
uh, let I want to do another one of these.
Yes. Let's do either 17 or 19, whichever you like.
Question 17.
17. Okay, let's go to 17. Okay, this one.
Yes.
Okay. Can you tell me the first derivative?
First derivative, that is going to be 3x plus x2 over 2 plus c.
Good. Use this condition.
That's this one. So now that's going to be 3 equals to 3. Oh, sorry. Let me do that again. 3 equals to 3 times 0 plus 0 squared over 2. So then
Plus
that's going to equal to, oh, plus c, sorry, plus c, forgot, plus c. All right, so then you're gonna get 0 on this side. So 3 is equal to c.
so C, you can replace the C with a 3, right?
Yes.
Okay, now tell me the function.
Function should be 3x plus x2 squared plus 3.
Oh, no, that was the derivative. You need to tell me the function. So take the integral of this.
Hmm? Oh, no, sorry, I didn't get up to that part yet. All right, so this is just a normal function. So now you're going to do 3x plus x squared over 2 plus 3. So then you're going to get 3x squared over 2 plus, so you could break it up. So you could do 1/2, yeah, 1/2. It's really like 1/2 x squared, right?
Yep.
So I could do 1/2. So I could do 1/2 x times x cubed over 3, or no?
And what does that become?
Then that becomes so if I multiply that, so then that would be 1 over 6 x to the fourth.
X to the 3 only. Why would you have a fourth power?
Sorry.
And you can think of it like this. If you have a term which is x squared, its integral will involve x cube only, only one higher.
Alright.
Right? Okay, keep going.
Oh yeah, you're right. Mm. Wait, but if I like split it like in two, like would I like integrate both of
No.
what I'm
So the constant actually comes out.
okay.
Okay. Just like here, you took the constant out, right? And only looked at x,
All right.
right?
Let me just write down
Yeah.
about constant.
It's called the constant multiple rule.
Right. Okay, good.
Okay. So make sure you have
The
x cube over 6 and then tell me what
then
next.
plus 3x
Yeah.
afterwards,
And then
then plus c.
another constant.
Right. Plus k.
Okay. Now
So
you
yeah.
use this initial condition.
Um, Just add this up together. All right, so now this is f of 4 equals 8.
Right.
So we'll do 8, 3, 4 squared over 2 plus 1, 6, 4 over 3 plus um 3, 4 plus c. So
Simplify it very carefully and then tell me what k you get.
you got see if I can shrink this because this is big on my screen. Okay. So this is going to equal to 3 times 16 plus 1. So this is going to be 48 over 2, which is 24. So 24, so 8 equals to 24 plus, let's see, 4 times 3. 3 times 4, 4 plus 2, 6. 64 minus 6. Let's see. I'm not leaving a fraction though. It's okay. So I'll just do 6 times 64 plus 3 times 4 equals 12. Plus C. So then I'll take all the stuff and subtract it. Let me see if I can get
Make sure
64.
you simplified the fraction. Did it become 32/3?
So do I do like 24 times 6 over 6?
No, no, you could simplify it, right? Does the 64/6 become a 32/3?
It does?
Doesn't it?
Let me see. Like if I do 64,
Do it on a
if
side
I
if you want. 64/6. Can you not reduce both by a factor of 2? 2 goes into 64 32 times and goes into 63 times.
oh, that's what you meant. Okay. Yeah, I can do that.
Yeah. Okay. And
So
also after that, I wouldn't bother adding this to the fraction because there are a lot of integers left over. So if
uh,
you're going to do k equals 8 minus 24 minus 32/3 minus 12, could you handle the integers first? 8 minus 24 and then a minus 12. Isn't that easier?
yeah.
Yeah. So do that first.
Yeah, you're right. So I wouldn't be like making them all equal fractions.
No, no, not yet.
Okay. Oh yeah, you're right. That does make sense. See if I can shorten this even short.
Make sure when you do that, you get negative 28.
C 18 and P plus 2 plus C 12 C 12. All right. So 24 P plus uh-uh. 24 times 3 plus 32 over 3 plus 32 over 3. All right, wait, you said to subtract them. All right, so you're just doing 12 then. So 12
Let me know when you get to this part.
times, yes, got it. So let's do 36 over. Well, okay, let's add 32, 68 over 3. What'd you say I had to get?
Did you get this part? The fraction
Uh,
remains as is, negative 32/13, but then you have a negative 28.
oh, no, I did not get that part.
So what did you do with 8 minus 24 minus 12?
So, where are you getting the 8 from?
8 was from the right hand, the left hand side, wasn't it?
So, yeah, but it's not in like the the part with K. It's just like that's what you're
Oh,
subtracting from.
yeah. So I'm putting k on one side and moving everything else to the other side.
Um,
Okay. Is that
oh,
what you
and
usually do to find k?
um, we keep everything on one side, then we put like what K is equal to.
Right. So I put k on one side and then push the everything on the other side. Does that give you 8 minus 24 minus this guy minus 12? Right?
6 minus 2. That's going to be 1 I have to make like the 8 like a fraction too if I need to subtract it.
Not yet. That's what I suggested earlier. You can take care of the integers first. That's easier to do. You can take care of 8 minus 24 and then minus 12. Can you do that first?
Yeah. Yes. Oh, that's what you're referring to.
Yeah.
Right. Minus 24, so that's going to be negative 16.
Yep. And then what about negative 12?
12. Let me see. 12. 12 minus 32 over 3. So I
No,
have
no,
to
no, no,
multiply
no.
by,
You already have a negative 16 from here, right?
right?
Right.
So
And then subtract another 12. Those are all integers. You can take care of that without fractions. What's negative 16 and then a minus 12?
that's going to be negative 28.
Yes. So now you have the
Okay.
fraction negative 32 over 3 and then a minus 28, right?
Alright.
Okay. Now, recall like denominators. How do you make a denominator of 3?
Sorry, what?
You want to subtract this. You want a common denominator.
Yes, right.
So what do you do?
You multiply the 28 by 3 and do the denominator by 3.
Fantastic. So what's 28 times 3?
Alright, 38 times 3, 84 divided by 3. 28. Hello?
What's 28 times 3?
20, oh, sorry, 28 times 3. 28 times 3 is 84.
84. So you have negative 32 and then minus 84. What's that?
Yeah, I divided it by, yeah, 3. The same answer. Okay, good. And then that's going to be 20 over 3. 84 over 3. Wait a minute. So that's negative 32 minus 28. If you divide 84 by 3, won't you just get 28 again? Oh,
Yeah,
wait,
but
just
we don't
subtract.
want that because you want to subtract this
Yeah,
because we have
right.
a
We
common
don't want.
denominator. Yeah, that's the whole
Right.
point of making a common denominator. And
So
also, I don't
that's
want to
going to be
spend too much
negative
time on the
1.
calculation. So can you check it's negative 116 over 3?
Yeah, I got it. That's what I
Yeah.
got.
And yeah, with that, you are almost done putting the value of k as negative 116 over 3 and reporting this as your final answer will get your job done.
Right.
Okay. 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 That's all about
Yeah.
differential equations. Do you have any questions in this part?
No, I think like the fractions was the only thing that was throwing me off.
Yeah. So try
Next lesson.
dealing with fractions on your own time. For now, we'll move on to the next part. Okay. That is
Right.
use substitution. Okay. So the idea about use substitution is that you're using the chain rule, but in reverse. So can you tell me how you would do this part? More importantly, what is the u that you'll substitute?
Is what's over in the parentheses.
That's a
So
good
like it's
idea.
x4 plus 3.
Yes. And what do you do next?
The derivative of u should be 4x third.
Yes. And I always like to write du instead of du by dx because that is 4x third, 4x raised to 3 times dx. Do you agree with that?
Yes.
Yes.
So then you take the beginning, you take like the coefficient 4, then you
Right.
do the reciprocal, so that's 1/4.
So does it go on the other side?
Uh yes. So it's 1/4 equals to the integral.
Well,
No, sorry. One
oh,
over four
du is x cubed
the
dx, right?
right.
Okay, now you look at the integral and then put in what you know. What is x cubed dx?
Let me see. So you could put the 1/4 outside of
Right?
the integrand.
Good.
And then you would do the derivative of u squared.
But not the derivative, but the integral of u squared, right? Because all of this is u squared, isn't it? Can you see that?
All right, let me see. There we go. 1/4. Okay, so then you do the integral of u squared, so then you get so then it's 1/4 times u cubed over 3.
Okay. Don't forget the
All
plus c.
right, and then plus c, yes. And then you multiply that, so then you would get, let's see, u3 over 7
U3
square,
over what?
u cubed over 7.
Or
Right?
is it
No,
7?
multiplying 12, so 12
12.
plus c.
Okay. But are you done?
All right, and then you put in then you put whatever u is in.
Good.
So like x4, x to the fourth plus 3 over 3. I mean, not over 3, to the square 3. Yeah, good.
Yes. That's a very good idea. Okay. Good.
So my question here was that I just have like issues when I don't know when to, like when the question arises, I don't know how to do the this part. Let me see if I can scroll in. How do you know what the constant multiple is? Because sometimes I get confused with that.
That's a very good question. What you should be on the lookout for is in your integral, what kind of expressions do you have? You have x cubed and a dx, right? When we found the derivative du equals 4x cubed dx, you should always look out for isolating x cubed dx. If you isolate this, you want to get rid of this part. So what do? You want to move this to the other side, right? Does that give you 1/4?
Okay.
Right?
Yeah, right.
So 1/4 du comes in place of x cubed dx, wherein the 1/4 comes out and the du comes in. That is how you substitute.
Great, perfect.
Okay, okay. It will become more clear when we do more examples. For now, let's try to do this one, shall we? Can you tell me what is the u that you use? And try to follow
U
the structure that
this
we have been developing. What is u and then what is du?
x, right. So x2 minus 5.
Okay, what is du?
Du 2x.
2x dx. Don't forget the dx. That is, most people forget the dx part. Okay, are you with me so far?
Yeah, sorry. All right.
Okay.
So then the constant multiple is 2, so then you would do 1/2 and then you do the integral.
Yeah, but before
Right.
doing that, it's always a good idea to write what the x dx is. So I'm going to put the 1/2 out and the du
All
in
right, yeah.
and then x dx so that it becomes clearer what you want to substitute. It's x dx, right?
Okay.
So this becomes, can I write it as 1/2 integral of the du goes in and then what comes under the root?
What comes under the what?
The under the radical sign.
Under the radical sign? No, like one half. Like no, like you put in
This
parentheses and then you put it to the 1/2 power.
that is better. Good. And what do?
Okay. So then you do 1/2 times the derivative of it. U,
Not the derivative,
U one
antiderivative.
half. So then you, okay. So then you add 1 to the 1/2 exponent, and then you get U to the 3/2 power over 3/2, and then you flip the 3/2, so it'll be 2U/3. Then you keep the 3/2 exponent on the U
Good,
plus
good,
C.
good.
All right.
Keep going.
So then what you do, and then you multiply the 1/2 by the U with the 3/2. So then you get 1/2. Then you put in the equation x2 minus 5, and then you put in
Make sure you simplify. What is 1/2 times 2/3?
what is 1/2 sorry, repeat. 1/2 to, okay, 1/2, okay, so it's 2/6, which is 1/3.
1/3. Couldn't you have just cancel the twos?
Yeah.
Yeah, okay. And then put the
All
u
right.
back. So you get x square minus 5 raised to 3 halves plus c. Okay, that's your final result. Okay, how do you feel about it?
I think this part I feel pretty good. It's just like the exponents that I mean the constant multiples that confuse me.
Okay, so for that, make sure you follow this structure. If you follow this structure, then it will become better. Okay.
So just checking to make sure. The constant multiple is based on like what the notation is, like x or x plus 3 and stuff like that.
Uh, no, it depends on what the derivative turns out to be. If du turns out to be 2x dx, then you find what is x dx in your picture.
All right. Do you do the derivative of that or no?
Yeah,
Of the x?
we need u. We need the derivative of u. That's what we need.
Yeah. Okay.
Yeah. Okay. Does that
All right,
answer your
good. Yeah.
question?
No, I understand that part, but like say if like we have, I don't know, what's a good example? There was this question I was having trouble with on my homework, I think. Say if we had 3x of 4, like how would, and we had like like the derivative of oh sorry, no, let me rephrase that. Let's see, the constant multiple I got was 20, but like what's in front of like what's in the parentheses is 3x4. How would I get the fraction to use in front of the integral?
Oh, that's a very good question. So let's say you had something like this, but then maybe you are referring to actually make up a question. Hold on.
I'll just send it to you. Yeah, I just sent it.
Oh, good. Okay. Oh yeah, that's a very good question. So 3x to the 4, 4x5 minus 9x. Okay, let's tackle this. 3x to the 4.
Okay.
X to the
Good.
5 minus 9. Does it look like this?
Yes, correct.
Okay. So for this one, you still do the same technique. You follow this structure, and then everything will be in place. For example, what is u in this case? Is it
Um,
4x to the 5 minus 9?
it should be x4 plus x to the 4th plus 3. Oh no, that isn't that the hmm,
No, no, no. What is
oh no, that's when you do the integral of that. Um,
if u is this? Can you tell me its derivative du?
all right. Oh, okay. So 5 times 4 equals 20.
20x to the
X4,
4,
the fourth
and then
power.
don't forget the dx. That is important. Okay.
Right.
Are you with me so far?
Yes, correct.
Yeah. Okay. Now look at the integral. You have x to the 4 and you have a dx, right?
Right.
So in your differential that you got, you have x to the 4 dx, you need to get rid of this 20. So what do you do with that?
Right.
Would you move it to the other side? 1 over 20 du equals x to the 4 dx.
All right. Yes.
Yeah. And now use all of this in your substitution. Put everything in. The 3 comes as is, right? Can you see that?
Yes.
Yeah. Okay. Now x to the 4 dx can be replaced with 1 over 20 du because of this.
Oh.
Okay. And you put what is remaining. The remaining part is this. What is this in terms of u?
Huh? What'd you say, sir?
What do you replace this with?
That the 4x5
Yeah, but what is it in terms of u?
terms of u.
Isn't that just
X.
u cube? Remember it was
Uh,
cube.
yeah.
Yeah. So this is how you do substitute. You take it part by part after you have taken the derivatives.
All right. Good.
Okay. Does that answer all of
Okay.
your questions for this one?
Yes.
Yeah.
Let me
Okay.
see if I can find the next one. Um, good for harder word problems. Let me see. 16.
What do you mean?
Yeah, that one.
Oh, this one. This one was not that bad.
Yeah. Okay. It's 6x. So then that's going to equal to 24 minus. All right. Sorry, where was I? All right. Let me see. Right. So then you do the integral of that, and then you get 12x cubed over 3, and then that simplifies to 4x cubed minus 6x squared over 2, which simplifies to a negative um yeah, negative 6x squared over 2, which would then lead you to f of x3. So minus, right? Minus 3x squared plus c. Yeah, that's the first part. And then the second part, um,
Use the initial conditions.
yeah, so then you should do the f of 3 equals to 15. So our times 3, 3 minus 3, 3 plus 3. Okay, let's see. Let me see. 3 times 3 equals 9 times 9 equals 27. 27 times 4. Let me use my calculator. So 3 times 3 times 3 times 4. Okay, so it's gonna be. Let me see. 9 times 3 equals 27. 9 times 3 equals 27. Let's see, then you subtract the 108 and then 27, and then you get 108 minus 27, and you get 81. 81 plus c, and you add that, then you subtract that to the 1. Three. Let me see this one.
Do you get c equals
So
negative
then you
69?
oh yeah, sorry, I forgot to subtract it. Right. Minus 50. So would it be let me see if I'm doing this right. Equals to 4x cubed minus 3x squared plus or is it minus? Plus or minus 66.
Minus
Oh yeah,
69, I believe.
69? I think I must have put something wrong.
I think you messed up this 3.
Yeah.
Yeah.
Yes. Okay. Yeah. Okay, good. So yeah.
Oh,
So
okay.
and then yeah, that
I want to
seems
be
good.
mindful of the time that we have. We are already comfortable with the differential equations part, and we are doing use substitution. Do you have any questions in use substitution? Or should we do some harder problems?
Yes.
Yeah, okay. Choose whichever you like out of 23 or 25.
Like 23.
23. Okay, good choice. What do you substitute u as? Try to follow the pattern that you have been developing. U is what?
Mm, mm, U equals sine of 5x
Sine facts. That's a wonderful idea. In that case, what is du?
du. Mm, wouldn't it be the derivative of sine equals cos of 5x?
Oh, but make sure you're using the chain rule. Do you recall your chain rule?
Right, chain rule. So cos of 5 of x and then you get 5.
Phi
So
offset
it's 5
and
cos.
phi cos phi x, and don't forget the dx output.
Right, yeah.
Okay, okay. Now again, you ask the question, do you have this appearing in your integral? So do you have cos phi x dx, right? Can you see that?
Wait, repeat that for me, please.
You have cos phi x dx in your integral.
Yes, right.
Yes. So you want to isolate this part, which means you want to get rid of this 5 somehow. How do you do that?
Divided or
Divide by
something?
5. In other words, move it to the other side.
Oh, 1 over 5. Oh, so you're working to get rid of the coefficient in front of the
Yes, yes,
derivative.
yes, yes. In front of what we actually want. We want just cos phi x dx, right? Okay. Okay, if you have that out of the way, then you can use your substitutions and do it one step at a time. What do you replace this with?
Um, this um sine of 5x.
That's sine cube of 5x. So what is that in terms of your substitution? Where do you see sine 5x?
I see sine 5x in the u.
Yeah, so isn't this just u cube?
Right.
Right. What is cos 5x dx? Where do you see in your substitution? Where is cos 5x dx?
I see it in the du. So
More importantly, it's 1 over 5 du.
5, yeah.
Yeah. So you can either put 1 over 5 du or you can put the 1/5 outside.
Okay.
Right? Okay.
Yeah.
So I highly recommend that you follow this structure. If you do this, then it becomes much more easier.
Just see that for a second, please. Let's see. Du. Right. Um, okay, and then you put in the u, which was sine 5 of x.
Oh, did you do the integral first?
Yeah. Oh, sorry. U4 over 4.
Yeah, and if you have 1/5 out, does the denominator ultimately become u4 over 20?
U4 over 2. Yeah.
Yeah, don't forget the plus c. Once you've done the integral, then you can put the u back. So what's your final result?
All right. So it should be. Sorry. This should be okay. Cos of. Let me see.
Whoa, 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 whoa. What was u?
Sorry. U was all right. U was sine of 5x.
Yeah, so it's going to be sine 5x to the
4.
fourth power over 20 and then a plus. Right?
Yes.
Good. Okay. Do you feel better about this now?
Yes.
Yeah. Okay.
Much better.
Okay. Let's see. Do you want to do 28?
Sure. Yeah.
Looks fun. Okay. Okay. What is your u?
My U, it should be cos of 9x.
Cos of 9x squared. Right?
So, yeah.
Okay.
And then the du of that should be negative sign.
Negative
Yeah.
sine, but then what about the chain rule?
Yeah. Okay, so it's negative 9x squared sine negative x squared.
No, no, no. You have to take the derivative of what is inside it. Isn't that what the chain rule says?
Oh, sorry. Yes, I forgot to do that. All right, 2 okay, so the 18x.
18x. And finally, don't forget the dx. Right? Okay. And make sure that what you are doing is a good substitution. Do you see that you have an x sine x 9x squared dx in your integral? You have x sine 9x squared and then dx. Right? If it were not the case, then you would have to try some other substitution. Okay.
All right.
Okay. I would want to get rid of this negative 18, so I'll multiply by negative 1 over 18 on the other side. Right? Don't forget the negative sign in this case. So if you put that negative 1 over 18 out, what remains inside?
Um, uh, yeah. Right. So then you do 1 over 18. Wait a minute. Why is it 1 over 18 again?
It's
Negative.
negative 1 over 18 because we want to get rid of this term, the coefficient out front. We moved it to the other
Right.
side. Yeah?
All right, let's see. Negative 18x over okay, 18x. Wait, no. You're doing the u first. Okay. So then it would be, wouldn't it just be u, or would it be u squared?
But which one is it? Or what is this remaining term?
Um, this squared.
It's u squared. So you put u squared in. Is that what you meant?
All right, and then you get u. Let me see. Right. Uh,
So do you get something
okay.
like negative u cube over 54 plus
Yeah.
c? Yeah. Okay. Check the calculations and once you put the u back, make sure you put the u correctly. So it's negative cosine cube of 9x squared over 54 plus c. Okay, how about that?
Let me just look at this for a second. Let me write this again, actually. 18 to the second, 2, 3, 4. Where's this? Where's this? My computer. Say -1/18, that's u over 2, so it should be u over 3 over 3. Um, okay, so -118 times, we see u3. Oh, already. They're getting close. So 54 plus c. All right, good.
Good. Okay. Okay. I would now move on to the next section, that is definite integers. Are you ready to do this?
That's fine. Evaluate definite, integral,
Yeah.
definite
Yeah.
integral. So it's the one
Okay.
with like b f of b minus f of a.
That's fantastic. Yes. So first you would look at the indefinite integrals, find the answer, and then put the bounds. Right?
Right.
Yeah.
Good.
Okay. Can you tell me the first one?
All right, yeah. So yes. So the integral for this one, we're first finding the integral. So then you're going to have x 3 plus x to the 3 plus 1, which is 4 over 4 minus 3x squared.
Okay. And I don't know what notation your teacher uses, but I like to use this bracket notation. I'm putting in the bounds
Yeah.
3 to 5.
And yeah, that we use the brackets.
Yes. Good. Which one do you plug in first, the 5 or the 3?
So the first one, so like b is on the top and a is on the bottom, so we plug in the b first.
Yes.
So
So you
like
put in 5 first.
5, like whatever you substitute with 5, you put
Yes.
that whatever you substitute
Yes.
with b. Yeah.
Yes. 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 So your final result would be something like 5 raised to 4 over 4 minus 3 times 5 squared. Make sure you use parentheses. And then you subtract 3 raised to 4 over 4 minus 3 times 3 squared. Is that what you meant?
Wait, repeat?
Is that what you meant? You put in 5 first, so you get this guy. And then you put in 3, so you get this part.
Yes.
Yes. And then make sure you are subtracting the whole thing. Okay. Can you actually do this for me and tell me what the final answer looks like?
Yeah, I could try. Okay.
Take your time.
Thank you. X or x squared. All right, so let me see. 5. Let me see, so that should be. You said to leave them in fraction form, right?
Well,
Okay.
I would want you to simplify it as much as you can.
Okay. 4, 3. 5 over 4 minus 3.5. Let's see. So it's 1 minus. Five over 4 see. Yes. See. Equals. Um, I think I did this wrong. I did 4 minus 3.5. Is it 3.5 squared or just regular 3.5?
Oh, no, no, it's 3 times 5 squared. Remember, it was
Oh,
3
three
x
times.
squared, wasn't it?
Right. So, right, 5 to the fourth over 4 minus 3 times 5 squared. All right, so let me see this one. 5 over 4 minus, see, 5 times 5 equals 25 times 3 equals 75. So, mm, times. So, let's see the numbers. Let's see. 5 times 5 times 5 times 5 plus for 40. Okay. Minus, see, 3. See, 3. So, oh, mm, yeah, that's fine. Okay, good. Can we do the one with the
But
pi signature?
did you get the answer 88?
Let's see this one. Okay, so it's, mm, you wanted it on fraction form, right? So let me
You
do
would,
it here.
you would actually simplify the fractions. It turns out to be an integer. Did you realize when you go through this work? Did you do this work?
So, yeah.
Yeah. So if you do that, then you should get something like this. I don't know.
Um, yeah.
So once you do, you should get your final result as 88.
Good. Next one.
Okay.
So we go 30, 34.
Do you want to do 33?
Let me see. 33. 34 is better for me.
33 involves a trig function. So let's actually do that because you need to get better at trig. Can you tell me what is the integral of sine x first?
Integral sin x would be cos of x
Negative
plus c.
cosines.
Right.
And remember, when you're doing definite integral, you don't need to put the plus c because it will eventually cancel out. So you can just evaluate negative cos x from 0 to pi. Be very careful with this negative sign. So first you would want to do negative cos of pi by 3, and then you would want to do
Right.
negative cos of 0. Do you get this part?
Right. Yeah. Uh-huh.
Okay, when you are ready,
Yes.
you have to tell me what is
Yes.
cos pi by 3, and you have to tell me what is cos 0.
Cos of zero is, what's cos of zero again? 1? Was it 1 or was
Cos
it
of 0.
0?
What about pi by 3?
That should be 6 cos of 60, right? So the cos of 60 is it like the, does this one have the radical? Um, So cos of 60 should equal, is it radical 3 over 3?
No, no, no. I think it's just
Let me
1
go
half.
back to my 1/2. Okay, good.
Yeah, okay. So when you put all of that in, what do you get? You get negative 1 half. And be very careful with this negative. I'm
Yeah.
going to put negative, negative 1.
Okay.
So what do you get? What is the final answer?
1/2.
1 half. Good, good, good. Okay. I see that you are comfortable with this, but I want to move on to what we left off in the first step. I want to do this
Yeah.
one, question 3.
Yes.
Okay. Try U substitution. What is U?
E substitution. Oh, nothing's anything. Is it x3 plus x minus 3?
That's one way to do it. Yes. So what is du in that
Yeah.
case?
Um, let me see. Um, okay, what's the u? What's the du? And I think we just use ln for these because like in the other one.
Not yet, not yet actually. It's part of U substitution. So let's follow the structure. Can you tell me the derivative? Is it going to be 3x squared plus 1?
Oh yeah, 3
Yeah.
squared plus.
And then a dx. And then you see that all of this is appearing in your integral, 3x squared dx.
Right.
Right? So this can be written as all of that is just du. And what remains is in the denominators. It's 1 over u. Do you agree with that?
Right. Yeah.
Yeah. And now what is the integral of 1 over u du?
Let me see.
That is the
So
natural log of u.
yeah.
Yeah. Plus c. And then you put the u back. Natural log, whatever was u. X cube plus x minus 3. I always like to put absolute values because natural log is defined only for positive numbers.
Let's see. Mm, and, okay. No.
Okay.
Um.
Do you see that you can actually use
Well.
U substitution to do all of this?
Mhm.
Yeah. Okay. Once you're done, we're going to do question 5 when you're ready. Let me know when you're ready.
Mm. So you're just gonna put like the denominator as a u, right?
Yes. Yes.
All right. Good. 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 Okay. Let me write it down. Denominator. Um. Next page.
Well, let me ask you a question. Here, when you went from here to here, why did you not use the
Yeah.
power rule, by the way? Couldn't you have written this as u to the negative 1 du and use the power rule instead?
Um. For us, like in power rule, you just take the What do we do in power rule? So power rule, we take the what's in the what's it called? The exponent, and then we
Add 1 to the exponent and then divide by that new
yeah, 1
exponent.
to exponent.
Is that what you do?
Like in like if you're doing like normal derivatives, like you would forget what I said. Continue, yeah.
No.
So we
Okay.
don't put it like as negative.
No, no, you usually do
So
this, but the problem with this is it turns out to be u raised to 0 over 0. And dividing by 0 is not possible. This is the
right,
problem. So that's why the integral of 1 over u is specially defined to be the natural log of u.
right.
Okay. Let's maybe do one last problem for the day, and then you can ask me any questions you want. Let's do this one.
Um, let's do another use of substitution. Oh wait, let me look and see if there's anything else. Okay. All right. Let's just do a use substitution.
Yeah, let's do this one. This one is actually u substitution. So can you tell me what will be u in this case?
It's y. Wait, what? Wait, say that
Oh,
again. Sorry.
what is u?
U is it sine squared?
Well, not sine squared because we'll take care of the square itself. It's just sine y. You'll think,
Sine y.
you'll realize why, because what is du in this case?
So let me see. Right here, this should be a cos
Cos
of
y
y.
dy. And this is where you decide whether this is a good substitution or not. You have cos y dy in your picture, right?
All right, yeah.
Yeah, so that's why you proceed. All of that becomes just du. And what remains?
So, wait, what were you saying? Sorry. Okay.
Cos y dy became du. What remains is sine squared y, but is in the denominator. So what do you write it as?
Right. So then, wouldn't you split it up? So like, would you put like cos over sine and then 1 over
No, cos y
sine?
dy is already part of du. All of this is just du,
Yes.
right? Isn't that what we
So
did?
yes.
Yeah. So what remains is sine squared y only. And that is also in the denominator. So first of all, you would do 1 over, but 1 over what?
Yeah.
If u is sine y, what is sine squared y?
View sine y was
Is it u squared?
um. Wait, repeat that. Sorry.
We want to know what sine squared y is, right?
Right.
You know sine y is u. I want to square it. So
Yes.
will that be u squared?
Um. Yes.
Yes. And how do you integrate this?
You integrate. You flip up the you flip up the u and then you put I think the 2 has negative. Yeah, negative
Okay.
exponent.
Okay. Keep going. Keep going.
Yeah. So then afterwards, s okay. So then you would do like the integral. So it'd be u minus u to the exponent minus 2 plus 1, and then it would be minus 1 on the bottom. Minus 1 on the
So
bottom.
yeah. So can you make sure
So
it
then you would get negative.
all of that simplifies to negative 1 over u?
Yeah.
Yes. Good. And don't forget to put the u back. So it's going to be negative 1 over sine y plus c. And in case you know a bit of trigonometry, you can rewrite this as 1 over sine is the same as cosecant.
Cosecant. Yeah.
So it's negative cosecant y plus c. This is some extra stuff if in case you are interested. If not, you can leave your answer like this. Okay.
Um, let me just write this down quickly. Squared u equals to 2u plus c should equals to negative sine y plus c equals see. Right. Let me see. Yeah, okay. So, see. So, 1 over u and let me see if there's anything else I want to do because I did that one already.
Oh, did you get this?
Yeah. Just like one question. Why wouldn't you like instead of like having like the 1 over 2, why wouldn't you split like the cos like the cos of y over sin over
Oh yeah,
sine? Sorry.
you could do that. You could. So actually, yeah, I did not realize you could split it into two parts. Do you want to do cos y over sine y and then 1 over sine y? Is that what you meant?
Yes.
Yes, you couldn't do this. What is cos over sine? Is that the same as a cotangent? Right?
Uh,
This part is
yeah.
cotangent, right? And this part is cosecant. So it
Right.
turns out that you can also do it this way, and this one directly gives you the integral of cotangent y cosecant y is directly negative cosecant y. So you still get the same answer, but in a different route.
Yeah, yeah.
Okay. Yeah. Good question, by the way.
Oh, thank you.
Okay.
I'm
That's all the
just
time
like
we have for now.